Hey guys, I'm back with a new video. So in this video I'm going to discuss about the problems on Poisson's distribution. But in earlier video, in the previous video, I have discussed about the binomial distribution, but in this video we are going to discuss about Poisson's distribution. Okay? Now, so we have a problem related to your Poisson distribution. Okay, the binomial distribution and Poisson distribution is almost same, but just with a minute difference it has. See, so which I'm going to discuss in this video. Okay, so let us understand how what the difference is between these two formulas. We shall see with an example. Okay, so we have an example like in a certain factory turning out razor blades, there is a small probability of 1 by 500 for any blade to be defective. ठीक है, so they are saying in the question that there is a factory which is producing some blades, blades, razor blades. Okay, so they have given a probability for a blade to be defective. If any blade is defective, then for that the probability they have given is 1 by 500, which is nothing but your 0.002. Okay, okay, noted. Next, the blades are supplied in pockets of 10. That means there is a pocket in which that pocket contains 10 blades. Okay, okay, I understood. So we are producing here, the factory is producing the blades in pockets of 10. That is, a single pocket contains 10 blades. Every pocket contains 10 blades. Okay, use Poisson's distribution to calculate the approximate number of pockets containing no defective, one defective and two blades in a consignment of 10,000 pockets. So they have given the probability for a single blade to be defective, and they are asking us, and they have said us that there will be supplied, the blades will be supplied in pockets of 10, and those pockets are 10,000. In this example there are 10,000 pockets, and in that pockets, how many pockets are in how many in the above in among 10,000, how many pockets have no defective blades, or one defective blades, I mean pockets, and two defective blades. Okay, how many, what is the probability, what is the, no, sorry, they haven't asked the probability, they has asked us to calculate the approximate number of pockets. Okay, pockets they have, how to calculate. Okay, so you have understood the problem. Now if you go back to your binomial distribution, what the formula we were using, we were first finding out the p value, then q value. Sometimes they would have been given these two values in question itself. Okay, okay, I'm saying about the binomial distribution. Remember, I'm saying about binomial distribution. So in binomial distribution we were having p and q value, and we were having a formula: p of x is equal to ncx into p power x into q power n minus x. So this was the formula. They would be, in question we will be given the n value, and p and q value we will be substituting, and x value depending upon the condition we were substituting, and we were getting the probabilities for each particular condition. Okay, that was the case for binomial distribution. But in Poisson's distribution, what is the case? Similarly, but here we need not, we should not find the p and q value. Instead, we have to find the mean value here first. Okay, well, let us discuss first what is the general formula for your Poisson's distribution. Okay, so my Poisson's distribution formula is p of x is equal to m power x e power minus m divided by your x factorial. Yes, your x factorial. Okay, so this is the formula for Poisson's distribution and this is the formula for your binomial distribution. Okay, fine. Now how will you implement this example by for this formula? Simple. So we have, so here all the parameters are known. X is the number, it is a variable which is we can substitute it in the formula by according to our conditions given. Okay, if no defective then x is 0, one defective, that is a basic thing, you know how to solve the probability. But what do you mean by m here? M is nothing but in our case mean value. Okay, mean value, that is nothing but it is denoted by mu. This is total. In Poisson's distribution the mean value is m. Okay, so this is the formula, only m, the mean value mu, that is which is denoted, sorry, the mean which is denoted by mu is equal to m. Okay, this is n m. But in binomial it was mean mu is equal to np, so it was np. Okay, but in our case in Poisson's distribution, mean, we have concluded that mean is equal to m. Why? In previous videos I have discussed about the mean and standard deviation of Poisson's distribution, in which we see in this derivation only, see mean mu we got, you can check it out my previous video in which I have discussed the complete derivation for the mean and standard deviation of my Poisson's distribution, in which we got mu is equal to m, standard deviation is equal to root m. Okay, now so my basic formula is this only, mean is equal to np, but in my Poisson's distribution I got m. So now if I need to find m is nothing but mean, right? Yes, we have concluded mean is equal to m. Okay, if I want to find m, what the formula I will use? Np. See, simple. Mean is equal to np and mu is also equal to m. So then if you substitute this formula, if you compare this formula, you are going to get this formula, m is equal to np. Similarly, by using this formula, first you have to find your m value. After getting the m value, you just need to substitute in this value, in this formula. After doing that, you need to simplify it using calculator, use a scientific calculator, and you need to go on changing the x value depending upon the condition. In first condition, no defective means x value 0, one defective means x value 1, two defective means 2. Khatam. Okay, so let's proceed. Okay, so I have this formula, Poisson's distribution. So in my case, p of x. Okay, first I have to, what I have told, I have to find first mean value, that is m is equal to np. In my case, what is the n value? Don't get confused. Okay, I have 10 blades in a single pocket, and there are 10,000 pockets. You need not to consider the pockets, 10,000 pockets. No, you have to consider the blades. There are 10 blades in each pocket. That means your n value is 10. Simple. And your what is p? Nothing but if there is a small probability of 1 by 500 for any blade to be defective. That means each blade, if any blade is defective, for each blade to be defective, the probability they have given is 1 by 500, which is nothing but 0.002. And if you multiply these two values, 10 into 0.002, your answer will be 0.02. Clear? Okay, so you have got your mean value 0.02. just you substitute in this. Okay, I will substitute. P of x is equal to m is 0.02 whole power x into e power minus m. Be careful, minus m is nothing but you have 0.02. Okay, divided by x factorial. Okay, now you will proceed as follows. Just you will substitute this x values here and you will get the answer. No, but it's not like that. See, this is the probability for only a single pocket, right? This I have done by how I have got this, by considering my n value as 10. Why I have considered 10? Because I have 10 blades in a pocket. So so this will be my probability for only one pocket. But similarly, I have 10,000 pockets. What to be done? Just multiply this this whole term by 10,000 on both sides. Simple. 10,000 into P of X is equal to, multiply this side also, both side. Whenever you are performing any multiplication operation, then you have to perform at the both the sides, left hand side as well as right hand side. Okay, if you perform 10,000 multiply 0 to whole power x into e power minus 0.02 x factorial. Simple. And 10,000 into P of X, you can replace this whole term with a single variable. I will take f of x. Khatam. Okay? And now you can simplify it. See, 0.02 whole power x can't be simplified because x value is still missing, x factorial. But you can multiply this 10,000 into e power minus 0.02. Just do it in your calculator. 10, this is my 10,000 into e power minus 0.02. You are going to get 9801.98. ठीक है ना? Yes. Yes. 9801. You are going to get the value. Okay. 0.98, that is 0.9801.98 is nothing but approximately 1 only. So I will consider only approximately 9801. I will consider it. Okay na? Okay. Now what I need to do, just I have got this formula. Now just proceed. How to do? Just now apply the conditions. Now apply the condition. Now everything is set. Now just apply the conditions and proceed. First condition, for first condition, how many, what are the x values? Now just I have to put my x values and then substitute it and get the answer. Okay. Now the pockets that have no defective means, for first condition x value is 0. Just substitute in this. F of 0 is equal to 9801. That is 0.02 whole power 0 divided by 0 factorial. Okay, you just substitute in your calculator. Anything to the power 0 is 1 and 0 factorial is also 1. Then the remaining will be f of 0 is equal to 9801. That means there are 9801 pockets that have no defective blades. Clear? No defective blades. Not even a single is defective in your 9801 pockets. Okay na? Okay. Now moving to our second condition, that how many pockets contains one defective blade. Okay. So how, just you substitute x value is 1. Substitute in this formula. F of 1 is equal to 9801 into 0.02 whole power 1 divided by 1 factorial. 1 factorial is 1. Just you multiply 9801 into 0.02 into your calculator. 9801 into 0.02. Your 196.02. 196.02 is approximately 196. F of 1 is equal to 196. That means there are 196 pockets of blades that contains only one defective blade. Only one defective blade. This is for no defective blades. This is for one defective blade. And the last one is two defective blades. Okay. Just in place of that, similarly in this formula what I have shown you, this formula, you need to put the x value as 2. Why? Because there are two defective blades. X value is 2. Put it, substitute in this and comment me the answer what you have got. Okay, I'm not gonna show it, but it's okay. I'll just show you the answer. You cross verify it. Okay. So this third one answer will be third condition will be 2. So there will be two pockets. There will be only two pockets which contains only two defective blades. Okay. Just you try to verify it. How I have done the same method. Just you need to put x in place of x value. You need to put 2. Okay na? Okay. So this is what the Poisson's distribution is. It's very easy. Okay, so in next video I'm going to talk about how to identify that a particular problem to be, that we have to do Poisson's distribution, or either I have to solve it by using binomial distribution method. They will not mention in my question that what by using what method we need to solve. We have to identify that what type of problem it is, and how on based on what parameters, what criterias are there, that which we can, by seeing which, by following which, we can identify that this problem is need to be solved with using your binomial or your poissons. Okay, in next video I'm going to say that. Till then, bye, thank you.